Good morning, everyone, and welcome to the first CAPTUS dissemination workshop called Unlocking Carbon Capture Technology for an Eco-Industrial Revolution. Welcome. I see we have already numerous attendees to our event, and I'm Irene Pauletti, Project Manager at EEIP, Energy Efficiency in Industrial Processes, and I'm organizing today's session with my team here. So the aim of today's session is to give you an overview of the EU-funded project in which we are a member, CAPTUS, which aims to demonstrate sustainable and cost-effective pathways to produce high-added value renewable energy carriers in energy efficient industrial sector by valorizing industrial carbon emission and integrate renewable energy surplus. We seek also to promote synergies with sister projects, and therefore we invited SINNOGENES and Fuelgae to offer an overview and spread our engagement in industrial decarbonization. Thank you again for joining, and look forward to productive and engaging workshop. So let's move. Before starting the main discussion, a few technicalities details. This is a recorded meeting for communication and dissemination purposes. Please mute yourself while other presenters are speaking and during the panel discussion, and kindly address any kind of question in the chat. We will monitor your comments and report everything to the main panel discussion afterwards. We have here Anna, and for any kind of detail, you can find our email in chat. Thank you for your help. So now let's go to today's agenda. Konstantina Plakaki, Policy Officer at the Hellenic Ministry of Environment and Energy, will set the stage of today's discussion with a keynote speech. Next, we will start introducing the three projects today. First, Dr. Monique Bernandez-Figuero, Technology Project Manager at CIRSE and Technical Coordinator of the project, will introduce giving an overview of the project. Then will be the turn of the two sister projects. First,
sí, yo creo que está bien.
First, SINNOGENES, presented by...
Sí, que está un poco más abajo.
Sorry, we are having some echo. Okay. First, SINNOGENES, presented by Dr. Ilias Zafiropoulos, Technology Director at Ubitech Energy, followed by Fuelgae, presented by Dr. José Campos, Scientific Researcher at CSIC. We'll then move to an interactive assessment presented by Dr. Stefano Barberis, researcher at Unigenova, who will assess the audience on some definition related to renewable energy, drawing from the policy framework. Finally, we will conclude with a multi-stakeholder panel discussion moderated by Dusan Jakubovic, Policy Director at EEIP. And together with the three project presenters, we will hear from these different experts, all engaged in the field of energy efficiency and carbon capture. We will have the pleasure to hear from Filippo Gasparin, Project Manager at CINEA, Dr. Milana Ayzenberg, Chief Technology Officer at CAOX, Marine Cornelis, Executive Director at Energy Consumer, Next Energy Consumer, and Professor Pelayo Garcia de Arquer, Group Leader at ICFO. So we will get insights to understand the barrier to technology adoption and potential solution to support development and deployment. We will emphasize the reason of the importance of collaboration through our common engagement and identify successful strategy. We will conclude with final remarks. So now let's begin our discussion with the first intervention of the day, and please welcome Konstantina Plakaki, Policy Officer at the Hellenic Ministry of Environment, with a background in physics and waste management and extensive experience in EU ETS, National Administrator for the Greek part of the Union Registry, Konstantina will set the stage of our discussion. So Konstantina, the floor is all yours.
Good morning from Greece. I'm very glad to start this event by a small introduction of carbon capture utilization. So carbon capture utilization is the process by which carbon dioxide emissions produced by burning fossil fuels or by other sources are trapped and then used so that they cannot affect the atmosphere anymore. As global warming increases, the process of carbon capture utilization is becoming more and more important to mitigate further harm. What are the main procedures for capture? It depends on the source of CO2. First option is if CO2 derives from an industrial plant or for a biomass power plant, then there are certain technologies that separate carbon from the rest of the gases and isolate it. Second options, direct air capture. The atmospheric the air is drawn through a gas trapping system where CO2 is isolated from the rest of the air and then released to be used. The utilization of carbon dioxide in production processes refers to technologies and procedures which use CO2 as a feedstock and converting it into value-added products such as polymers, building materials, chemicals, and synthetic fuels. Why we need CCU technologies? Europe has set two, let's say, big targets. First target is at least 55% net emission reductions by 2030 compared to 1990. And the second target is climate neutrality. This target requires that the Union shall aim to achieve negative emissions at the latest 2050 and thereafter. So it's crucial for Europe to support the development of technologies for achieving climate neutrality in 2050. According to CO2 Value Europe, CCU represents approximately the 21% of the overall GHG emission reduction that can be achieved through technological solutions in Europe. If we want to speak per sector, CCU represents reductions 20% in industry by using CCU fuels, by using capturing CO2 permanently in building materials via mineralization, and by using captured CO2 as a feedstock in chemical industry. What targets has set Europe in its policy to motivate the production of fuels by CCU? First of all, by the recast of the Renewable Energy Directive, let's say RED III, set obligations to use renewable fuels of non-biological origin in transport and in industry. Secondly, by the adopted regulation for refuel EU aviation, sets obligations to the fuel suppliers to blend increasing levels of sustainable aviation fuels in jet fuel taken on board at European airports, including synthetic low-carbon fuels known as e-fuels. For example, the target for 2025 is the use of 2% SAF, sustainable aviation fuels, and the target for 2050 is to use 70% SAF and 10% synthetic fuels. And finally, Commission, by the amendment of the main directive, of the main ETS directive, states that there is no double counting of CO2 from the use of CCU fuels, and then there is no obligation to surrender ETS allowances in the case of permanent binding of CO2. Following I will refer some arguments to prove that CCU is a central technology for the future. CCU provides renewable carbon as a feedstock that substitutes fossil carbon in sectors where carbon is an element feedstock, while maintaining the goods and services of these sectors, enables the fuel defossilization of the chemical and derived material industries as one of the three options of renewable carbon, is necessary to tackle Scope 3 emissions, which include raw materials and feedstock, and where CCU carbon uptake principally balances out end-of-life emissions. Of course, CCU generates value and drives innovation in many fields as a future industry that enables business cases, economic growth and prosperity, enables regional self-sufficiency of carbon feedstock because renewable energy and carbon from industrial point sources or the atmosphere can be found everywhere in the globe, enables the circular economy by facilitating the circularity of carbon, and last but not least, CCU can be implemented immediately without the need of enormous infrastructure investments. For many CCU applications, all that is needed is a local infrastructure for CO2 and access to renewable hydrogen networks. All at all, we have to mention that Europe has established some schemes to fund this innovating project, and I will refer 5 of them. I don't know is more. First of all, the Innovation Fund mobilizes over 25 billion euros over 10 years for technologies such as carbon capture and use. Connecting Europe facility supports cross-border CO2 transport networks. The Recovery and Resilience Facility aims to mitigate the economic and social impact of the coronavirus pandemic through investments in areas such as clean technologies, for example, CCU. Just Transition Fund provides support to territories facing serious socioeconomic challenges arising for the Transition Fund, from the transition towards climate neutrality. And finally, Horizon Europe supports research pilots and small-scale demonstration projects related to carbon capture, utilization, and storage. Thank you for your attention. I'm confident that our discussion today will be fruitful and will contribute to successful implementations of the CCU technologies. I have noticed that I'm very glad because there is one more Greek in the representatives. Have a good day from Greece. Thank you.
Thank you very much, Konstantina, for your insightful keynote speech, for highlighting the importance of CCU as technology of the future, without forgetting the importance of intervention at local perspective and important European instruments to support it. And I'm sure we will touch again this important topic later on in this discussion. Thank you very much again. Next, I would like to introduce Dr. Monique Fernandez-Figuero, chemical engineer and PhD on the valorization of pyrolysis products. Monique is here today as technical coordinator and representative of CAPTUS project to offer an overview after the first year from the start of our project. Monique, the floor is all yours.
Thank you for the kind introduction. I trust you hear me well. So good morning, everybody. Thanks for your attendance. It's really great to see so many people joining this session. Hope you'll have nice discussions afterwards. But now I'm gonna give you an overview of our project and what is the concept and at which stage we are now completing our first year. If you can pass the next slide, please. So yeah, the agenda is gonna be a small presentation. I'll give a little bit of the motivation for the project, the introduction, the concept of the CAPTUS project and the demonstration units, the structure, and some takeaway messages so we can discuss later. So first of all, the motivation for the CCU development is it was already mentioned by Konstantina, right? We have this European Green Deal in place. We need to reduce the emissions by at least 55% by 2030, which is very soon, and reaching carbon neutrality by 2050. So there is a lot of technology deployment that needs to happen, basically. And among the technology solutions, because there are many, this is not a problem solved by only one technology, but it is very clear that CCU is crucial, particularly for the sectors hard to decarbonize, such as the heavy-duty transport, such as aviation and ships. Also, some process industries, such as the energy-intensive industries, which are going to be looking into. If you can, yes. So this is just interesting data from a report that was issued, I think, last month. That was a modeling exercise issued by the CO2 Value Europe organization. It's just showing all the CO2 emissions, this blue bar, in which we have to avoid, right, to mitigate. And then this was a very interesting modeling study. You see that there are policy actions that can reduce the emissions, the CO2 emissions, societal choices, and inside the technology bundle, let's say, you have here the CCU that corresponds to 20% more or less of the possible reductions. So it is definitely essential to deploy these technologies, and that's, I think, the biggest motivation of the CAPTUS project. So about the project, it's the long title is the Demonstrating Energy-Intensive Industry Solutions to Produce Liquid Renewable Energy Carriers from Captured Carbon. This project started more or less a year ago. I am from CIRSE, and we are the coordinators of the project. And this project involves 18 partners from 8 countries. So what I find interesting to highlight is that CAPTUS is really coupling defossilization with decarbonization, because some industries basically is impossible to remove the CO2 because it's part of the chemistry, let's say. So we want to, let's say, not rely on fossil resources for the CO2. So we want to make it circular. And whenever possible, we want to decarbonize by electrifying steps of the process. So if you can pass to the next one. The current scenario of the CCU is there is a clear need to increase the TRL, increase the maturity of CO2 conversion technologies. So this is that now there is this very big push from the regulations and so on, and but still there is something that there is a lot to be optimized. There is a lot of granularities in terms of industrial CO2 because CAPTUS is focused on CO2 that is emitted from the industry, and as you can imagine, each industry will have a very different composition of the flue gas. Also, the supply is different, and this has to be taken into consideration for technology development. There is a huge interest in these novel pathways to make CO2 as exploitable resource. So not only storing it, but also converting it in materials and chemicals and fuels that are needed, because we do need carbon in our life. And there is a clear need to integrate different technologies to build the value chain. So we have the CO2 capture, we have the CO2 conversion. So this is something that it is a very multidisciplinary challenge. And that's what we aim to do in the project is to demonstrate 3 sustainable routes to produce energy carriers from CO2 emitted from these energy-intensive industries. And I'm going to talk a bit about the demonstration. So we have 3 demonstration sites. So the first one is in Belgium, is in a steel plant from ArcelorMittal. So in this demonstration, we're gonna take the blast furnace gases from the plant and pass through. This PSA is already installed, is already part of another very well-known project called Stilano. So here the idea is to separate CO and CO2 and purify the CO2. there is a lot of modeling here on the step of the optimization of the PSA. The CO2 stream then is going to be fermented first to acetic acid, and then a second liquid, the fermentation step is going to convert the acetic acid into TAGs, into this long chain triglycerides. This is being led by Bio-Based Plant Europe, and also CSIC is going to develop, is going to engineer some microorganisms that can efficiently convert the acetic acid to the TAGs. So this is our first demonstration, is based on fermentation technology. The second one is located in Portugal. So the chemical plant is HiChem, that is going to supply low CO2, that is quite variable, let's say, in terms of concentration and composition and flow. There will be a step of purification and conditioning by novice. And then the concentrated CO2 is going to be fed into photobioreactors. Here we have algae for fuel. And this bioreactor is going to, the algae, we're going to cultivate microalgae that are going to be, let's say, feeding on the CO2. And these microalgae are going to be converted into a bio-oil through hydrothermal liquefaction. So here CIRSE is also acting as a technical partner, let's say, not only coordinating, but here we're also performing this step. And as you can see, there is a simulation, and also I'm going to mention a bit this little icon here regarding renewable energy. But let me talk first about the third demo site, which is in Spain. It's in a cement plant in the north of Spain. Here, the gases from the cement emitted by the cement plant are going to pass by a continuous swing absorption reactor in order also to concentrate the CO2. And then we have an electrocatalytic step to reduce the CO2 to formic acid. So here the partners are SINTEF and the University of Cantabria that are really developing a very interesting process and electrochemical reactors to be very efficient on this conversion as well. You can pass to the next one. So the structure of the project, as I mentioned here in orange, you have the three work packages. Each one is devoted to a demonstration, to a demo plant. So here we have all the, let's say, more technical work packages. We have the transversal packages with CIRSE as coordinator and SIG as the communication and dissemination partner. And then we have baseline validation with RINA and CIRSE and exploitation with EEIP, if you can go. So here, just to share a bit that beyond the technical parts of the project, there's very interesting activities going on that are related to renewable energy integration and to avoid curtailment. So this is a very strong part of the project as well. It's not only validate the technologies, but also to try to integrate renewable energy, because CCU needs energy. So we need to make sure that this energy is going to be renewable. It's not going to contribute to carbon emissions, let's say. Otherwise, it doesn't make much sense, right? So here it's an important part of CAPTUS. There is also non-technical barriers that we're looking into, sustainability KPIs, impact evaluation, LCA. There are lots of tasks devoted to modeling the process, because digitalization is also important for making the process more efficient, more controllable, more transparent, and so on. In CAPTUS, there will be the development more later on the project of an energy management system. So the idea is to harness the local renewable energy potential, to minimize the price of the electricity, to be able to predict. So let's say to have a bit more control based on the electricity market. And techno-economic and thermoeconomic analysis will be also taking place during CAPTUS. In the part of exploitation, we have the lessons learned, we have guidelines to ensure replication of the technology, the exploitation routes, so let's say direct product commercialization or technology transfer, this is going to be explored as well. The barriers and let's say the opportunities and of the regulations, so how ready is the market for this technology, how ready are the regulations to, let's say, implement these technologies, business models. So let's say all this part of overcoming technical, legal, social, financial challenges are going to be explored as well. and the assessment of digital and social readiness, which is also very interesting to see how people, how the public, how the society are viewing these kind of technologies. And you can go further. So I go to the takeaway messages. I think I'm good on time. So first of all, it is impossible to reach net zero without CCU deployment, CCUS. Not every process can be decarbonized, so it's very important to leverage the circular carbon to convert it into something useful, so we don't need fossil-based resources for some kind of carbon-based materials and chemicals. Of course, we need to emit less, so that's why it's important to improve efficiency, to digitalize, to electrify processes whenever possible, and to ensure industrial symbiosis. And the non-technical aspects are as important as the technical one. So we are tackling this challenge from a very, very multidisciplinary and very nice team. And we hope to, in the coming 3 years, because we already have 1 year gone of the project, but in the coming 3 years to continue having events and sharing and discussing our technologies. Thank you very much for your attention.
Thank you very much, Monique, for this very clear and extensive overview of our CAPTUS project. I will welcome already the second presenters, Dr. Ilias Zafiropoulos, Technology Director at UBTech Technology and representing today SINNOGENES. Ilias, the floor is yours.
Thank you very much. Hello all. I will be presenting the main ideas and technologies that are developed during the project SINNOGENES. Next slide, please. So SINNOGENES, very briefly, is a project that delivers storage innovations for green energy systems. The motivation behind SINNOGENES is to satisfy the need for innovative storage solutions to ensure environmental sustainability and increase penetration of clean energy. Effective storage plays a pivotal role, of course, not only in the clean energy penetration, but also on power system reliability, resilience, adequacy, and quality of supply. There has to be an identification of the technical requirements that will push the multi-vector storage services in European and national regulatory frameworks. So this is also something that it is dealt in the context of our projects. And also there has to be a connection and usage of energy storage systems with existing platforms, ensuring multi-vector interoperability across consumers, markets, devices, and energy carriers in the system. The objectives of SINNOGENES is the development and showcasing of a versatile suite of energy storage technologies that covers thermal, electrochemical, electrical, and mechanical storage. We will create optimization tools for the collective potential of storage for energy arbitrage, peak saving, and flexibility services. We will harmonize the cooperation and the coordination of energy storage solutions with local renewable sources. We'll also integrate innovative storage solutions in real-world scenarios, in field demonstrations with a practical impact that has to do with the effectiveness in enhancing the energy efficiency, the resilience, and the flexibility of the energy system. And we are engaging diverse end users and sectors that provide practical, scalable, and economically viable models for energy storage adoptions across all sectors. So the project storage, the SINNOGENES designs, develops, and applies the SINNO toolkit, which is the set of a toolkit for the management of a different spectrum of storage technologies. Covers a plethora of sectors and applications involving widely adopted and commercialized options that we have for storage, like hydro pumped storage and lithium-ion batteries. We have also emerging technologies still in the R&D phase, like power to gas, which is potential sort of low cost and long duration energy storage. We include technologies with significant diversity in terms of their operational features and technological maturity, factors that will significantly influence their respective roles within the power grid. This is a diagram of the different technologies that we demonstrate in the project, as well as with respective digital tools that support the coordination and optimization of their operation. This diagram shows flywheel ultracapacitors that are, let's say, more for distributed services, going up to more bulk services with lithium-ion, flow-based batteries, thermal heat storage, hydropump storage, and power to gas, and also from short-term to long-term energy storage. Next slide. Okay, this is the a brief, let's say, mapping of the different demonstrations that we have in the project. Our project includes 27 partners and has 6 demo sites in 5 different European countries. It engages different environments and demand sectors. We have industrial sector, residential, services sector, agricultural, and mobility sector. There is a cross-energy carrier integration potential through coupling electricity with heat and hydrogen storage. The first demonstration is in Portugal that engages batteries, thermal storage, and electrolyzer in a large industrial microgrid. The second demonstration is in Spain, where geothermal energy potential is integrated for district heating in urban microgrid. The third demonstration is also in Spain, where we have a local energy community that optimizes the various distributed assets of renewable and storage. The fourth demonstration is a site in an industry in Germany, where we have optimal integration of heat and electricity storage in the industrial microgrid. The fifth demonstration is a digital twin of the hydro pumped storage in a non-interconnected island of Icaria. And the sixth demonstration is in Switzerland that integrates energy storage and distribution of hydrogen to urban and freight mobility. So the different SINNOGENES activities include the development of integrated energy management tools and digital services to optimize the operation of energy storage in the different environments. So we have different time horizon, from short-term time horizon, intraday real time, medium-term horizon, day ahead to week ahead, or also long-term time horizon for planning. We demonstrate flexibility services, frequency regulation, black start, voltage support, congestion relief, and demand response. We have an extensive digital twinning capabilities for our tools, so we can have a very high TRL level. The applications on field and simulation studies includes planning and operation of energy storage system locally, the management of hybrid storage technologies to provide flexibility services, operational efficiency via energy sector coupling, system planning of interconnections between remote areas, islands, outermost regions with insufficient grid capacity, and a stable or long-distance connection to the main grid, valorizing large-scale energy storage. We are also leveraging energy storage for energy efficiency and grid flexibility in the transport sector, which is also very important. We demonstrate resilient operation in industrial microgrids and energy communities, leveraging renewable energy sources, thermal energy, and hydrogen storage. Apart from these technologies, the digital tools, the applications on the field, we have also an extensive, let's say, extensive energy studies regarding environmental and economic impact assessment. We have a life cycle analysis and life cost analysis provided to assess the life cycle environmental and economic impact of SINNOGENES technologies, considering predefined key performance indicators. We develop business models for energy storage technologies market uptake across Europe. Targets at validated business models for the exploitation of SINNOGENES energy storage technologies and applications, leveraging the output of the environmental and economic impact assessment. And we include also a techno-economic analysis framework based on Artellis Crystal Supergrid modeling platform. These are the various stages of the methodology that we will follow, the steps that we will follow during the project. We had finished the pre-development phase, including the analysis of technical and market compliance requirements, the definition of the business use cases based on the stakeholders' input, and we are also finalizing the design of the main ICT architecture of the project. Now we are also into the phase of the development of the SINNOGENES various optimization tools and coordination tools for the storage technologies. We are developing the ICT architecture. We started developing it, and also we are setting up the requirements for the field deployments and integration in the various scenarios. And then we will have the demonstration campaigns and the valorization of the project with the various scalability and applicability studies and pan-EU scenarios. So that's all from my side. I don't know if we have something else. Thank you very much. This is also the consortium. We have a very wide consortium and very competent partners that support us in these activities. Thank you very much.
Thank you very much, Ilias, for being with us. We are linking your project in the chat so audience can take the chance to have a look, but also I would encourage to, since you are here, you remain for the panel to have to report any kind of question for you. Thank you. Now I would like to move to the second sister project, Fuelgae, presented by Dr. Jose Campos Martin, scientific researcher at CSIC and member of the management support team of the project and Work Package 6 leader. Welcome, Jose, the floor is yours.
Thank you very much for this kind presentation. I want to introduce this sister project is Fuelgae, is sustainable on-site and innovation technologies for the advanced transport biofuels from microalgae. Next slide, please. This is a project funded in the Horizon Climate and Energy and Mobility, and in the call of development of algae and renewable fuels of non-biological origin. This is a research and innovation action with a budget of about 5 million euros. We started about 9 months ago, 9 months ago in October 2023, and the duration is 4 years. We have 12 partners and 1 affiliate entity from 6 countries. Next slide, please. This is a research and innovation action that makes it pretty different than the 2 other projects that have been presented before, because we are doing a research to establish new knowledge and explore new or improved technologies. This means that we are to develop to reach technological readiness levels lower than is expected in the other 2 sister projects. We will reach a final technology readiness levels 4 to 5 for each technology validated in lab scale or technology validated in relevant environment. Then our technology is in lower development than the presented in our projects. Next slide, please. The expected outcomes are increase the feedstock and technology for the basis of renewable fuels, facilitate the development of advanced high-quality biofuels from algae lipids, foster the development and technological pathways for algal and non-biological renewable fuel production, increase the robustness of conversions, contribute to the priorities of the European Union of achieving zero emission by 2050, and deliver technology to meet the longer-term needs for renewable fuels in the energy and transport sector. Next slide, please. This is a scheme of the project. We will start with two CO2 sources, pretty different. One is from a steel plant with a low concentrate CO2, and the other one is the CO2 emissions from bioethanol second generation plant, and 2 of them was going to a closed photo bioreactor, and then we grow the algae, and then these algae will be treated and fractionated in 2 different fractions. One of them are a polysaccharide rich fraction that will go back to the bioethanol plant and converting more bioethanol. The other fraction will be transported to the biogas transformation, and This biogas will be used in the steel plant to produce heat, and another fraction will be used in the hydrothermal liquefaction and produce biocrude that will, in combination with the lipid fraction, will be treated with advanced catalytic transformation with using green hydrogen in advanced liquid fuels. And these advanced liquid fuels will be standardized and checked that reach the needs of the market. The idea to obtain a holistic use of all of the carbon produced, also the biochar will be using as as agricultural amendment and to improve the agriculture production. All of these are involved using with digitalization and modeling plan with additional path tools and digital twins, and all of these will be checked with life cycle analysis. Next slide, please. The project aim of 4G is the development of advanced liquid biofuels from two different CO2 sources. One is the biorefinery and the other is an energy-intensive industry through microGs. These advanced liquid fuels will be addressed by developing several technologies. Micro-G will be customized based on the needs of each industry on the case study. It's pretty different the use in the steel plant and the biorefinery CO2 sources. A photobioreactor plant will be integrated into the existing infrastructures of the two industrial sectors. Novel treatments for resulting microalgal biomass will be developed. An innovative multifunctional catalyst upgrading system for advanced liquid fuels production will be tested. Biochar produced as a side product will be tested in agriculture as a soil amendment. New family of sensors will be integrated in process analytical techniques, and the global digital twin will be developed. LCA and TA will ensure that the final product will achieve reduced greenhouse gases emission and economically viable. Next slide, please. Well, we are at the beginning of the project, but we expect several milestones during these 4 years of the project. The first one is in next October that will be reach the KPI and end user requirement for the preliminary model of 4G biorefinery. In November, we got the first micro-G batches with micro-rich in polysaccharides and lipids. The March 2025, we selected 2 micro-G species in the case studies. In April of 2025, next year, we'll give a sensor functionality testing in the lab environment and connection with the digital twin models. In March 2026, we will obtain an optimal fractionation methods to be selected. In June, the optimization of catalytic conversion to produce advanced liquid biofuels. And in March 2027, at the scene of testing of HTL and hydrotreatment scale-up in Greece. In April 2027, optimization of the bioethanol and biogas production. July 2027, micro-G pilot validation in Spain and Romania. In September of 2027, we will finish the project. Next slide, please. This project consortium, as I said before, is 12 partners and 1 associate partner. It's a combination of academia and LTO's institution, like the Spanish National Research Council, IT Research Center, the Center of Research and Technology ELAS, VTT Technical Research Center in Finland, University of Oulu, and National Technical University of Athens. So, I mean, two industries, ArcelorMittal Tubular Products in Romania, and Hellenic Petroleum, and SME, an association, that is Analysis DSD, RTDS Association, Intercom Commercial Pathways, and Perseo Biotechnologies. Next slide, please. This is the real team that we meet together. Then two meetings. One is in the upper part was the kickoff meeting in Madrid in last October. And the second one was in Finland in March, in April of this year. And next slide, please. Of course, we want to acknowledge the funding of the European Union. This project was founded under the grant agreement in this picture. Next slide, please. And all information, extra information that you will need will be in contact with the project coordination, Silva Morales de la Rosa, and dissemination and communication responsible, Janet Orayeva. Visit our webpage, fuelgae.eu, or visit our social media. Okay. Thank you very much for this opportunity.
Thank you very much, Jose, for highlighting your engagement in a technology that will allow for sure future collaboration with our project together with Sinnogenes.
Sure.
Okay, thank you again to all the three presenters. Now let's move to the interactive part of this session. To participate, we will project a QR code later, and this session is by Dr. Stefano Barberis, researcher at UNIGE. Hello, welcome, Stefano. You can start presenting your task while we'll allow the audience to enter into the Mentimeter. In the meantime, we will leave the opportunity to enter through the link. So,
can you hear me?
Yes, we can.
Okay, perfect. Good morning, everybody. This is Stefano Barberis from University of Genova. As Monique introduced you, in our CAPTUS project, we are going to, let's say, produce and develop processes for the production of renewable energy carriers. But our renewable energy carriers that comes from captured CO2 theoretically cannot be fully defined today as renewable fuels or biofuels or alternative fuels. So there are different, let's say, definitions that are currently present in the European regulatory framework. There are in the European regulatory framework that can be somehow adapted or approvable, let's say, for our CAPTUS renewable carriers. In the next slides and through our Mentimeter, we are going to propose you some definitions that could be posed to our CAPTUS renewable energy carriers to be checked if they are aligned to the European directive. The first one is alternative fuel. So according to the European directive and the declaration from 2014, alternative fuels means fuels or, let's say, power sources that serve as a substitute for fossil fuel sources in the energy supply, let's say, to transport energy as well as to let's say, for example, feed in and fuel in vehicles or transportation or power cycles. Let's say, looking and considering the CAPTUS renewable energy carriers that let's say Monique introduced you, what is your feeling? What is your first reaction. Do you think that CAPTUS renewable energy carriers are, let's say, alternative fuels? Do you think that CAPTUS renewable energy carriers can be aligned with this first definition? So let's go to the first question. This is, let's say, a question that is as scheme, let's say, as a scheme. We will replicate for all the other definitions that we will propose in the next. So, do you think that alternative fuel definition is adherent and suitable for CAPTUS renewable energy carriers? Please choose between no at all or no, not properly. So maybe it's not the best definition, but it could work. The definition is not perfect, but it's not work. That means better yes than no, let's say. And yes, definitely, if you think that is completely aligned, this alternative fuel definition to our renewable energy carriers.
Thank you, Stefano. While we are waiting for responses, yeah, just a reminder, I also linked the browser version, because if you didn't have the time to scan through your phone or you don't have the phone in your hands now, you can access from the laptop, and yeah, will be projected on the site. So yeah, see there are responses coming.
Can you place the definition on the chat, or like a print screen of the first?
Yes, I can. Yes, give me 1 second, and I can copy and paste the alternative fuel definition.
Just yeah. Thanks.
Just also for your reference. Second, really. So generally speaking, fuel and power sources that serve at least partially as a substitute for fossil fuels, let's say, in energy supply and also transportation sector. So as you can read, it's a quite generic, I would like to say. I don't want to interfere with your votes, but it's a quite generic definition in this for this. Okay, definition is not perfect, but it can work. Okay, let's go to the second potential definition. The second potential definition is related to biofuels. As said in our processes, we are going to evaluate, let's say, valorize CO2 via biotechnological processes. So somehow we can consider that we are dealing with biofuels. Biofuels are fuels that derived directly or indirectly from biomasses, used for non-energy purposes, and let's say they can be split in 3 categories, so solid, liquid, and biogases. I also put on the chat the definition, so I think we can proceed with the vote. Let's say when we talk about, okay, great, let's go to the second question. The question and answer, let's say potential answer, are very, very similar to the previous one. So we are asking you if the biofuel definition is adherent and suitable for CAPTUS renewable energy carriers. The options are the same as earlier. As you could see, let's say here we are talking about fuels that are derived directly or indirectly from biomass. So biofuels can be also used for mostly for energy and transport purpose, as we said earlier, while biolubricants or other types of, let's say, purposes that are not directly related to as fuel or for transport energy only are not considered in this category. As you can read, the definition is mostly focused on directly or indirectly from biomass. Okay? So in our case, it's true that we are using a biotechnological process, but let's say we have to understand where is this biomass origin, maybe. So again, I don't want to interfere, but just some food for thoughts for your answer. I think we are very, very close last 30 minutes. Remember also of the fact that our renewable energy carriers are not all, let's say, in a single phase. So I mean not only liquid or not only gaseous. One relevant aspect is also the fact that sometimes biofuels are directly fed in by national incentives. So the fact that we cannot be considered as biofuel can, let's say, prevent us to be supported by national incentives. Okay, I can see the answers are very similar to the previous ones. So let's go to the third one. We are talking here about renewable fuels from non-biological origin. This is a definition that is coming from the RED II directive, so quite recent. And we talk here about renewable liquid and gaseous transport fuels of non-biological origin. Here we can envisage more or less everything that comes from also power to X, so hydrogen, hydrogenation of CO2 via e-fuels, synthetic fuels, because the definition talks about fuels that are other than biofuel or biogas. So the question is again the same. Consider in your answer again, as we did for biofuels, that even for RFNBOs, so renewable fuels non-biological origin, in some cases national incentives are supporting this type of definition. So let's say the fact that we can consider our CAPTUS renewable energy carriers renewable fuel or non-biological origin can be a plus. Just maybe some food for thoughts for your answer. In our case, of course, we are valorizing captured CO2. So potentially we are talking about something from biological origin in case, for example, the captured CO2 comes from an industrial process, as in some of our use cases, as you could see from Monique's presentation. But let's say maybe if you answer in a way in this question, you have to be careful not to be obviously in contrast with the previous question, because in the previous question we were mostly declaring and trying to define our renewable energy carriers as biofuels. Okay, so while here is explicitly stating we talk about things that are non-biofuels, so not from biological origin. Okay, so let's see. I'm quite curious of this answer because at the end of the day, as I said, somehow is in contrast with the previous question. One important aspect that I did not mention is that your answer will be very relevant for us also to guide the activities related to our task in Work Package 8 to the definition of a let's say correct regulatory framework for our renewable energy carriers, also to understand what could be the most suitable regulatory framework, what would be the closest one, and how to adapt it to our renewable energy carriers or vice versa. Okay, the situation is still balanced, but I can see more yes, definitely. So glad to read them. Let's go to the next one, the last one actually. We are now talking about carbon neutral fuels. Carbon neutral fuels are fuels which produce no net greenhouse gases emission, meaning that the overall carbon footprint of the production of these fuels is compensated by the fact that some CO2 has been valorized or CO2 that has been captured has been used by feedstock. Let's go to the question then. Even in this case, I would like to highlight that this definition that you can read here is not coming from a European directive. I think we can go to the question. Let's say this definition is a definition, I would like to say, more academic, but from a certain point of view could be seen somehow quite adherent to our one, because at the end of the day, it's true that we are producing some CO2 during the fuel conversion, because in case our renewable energy carriers are used, for example, in a power cycle or in a transport or in an industry. Of course, they produce CO2, but let's say the emitted CO2 is maybe compensated by the CO2 that has been captured in the production phase of the fuel itself, because we used it as feedstock. I would like to highlight one aspect on this definition. As I mentioned, this definition is proposed by us, so it's more academic. I would like to, as I said, it's not coming from a real European directive, but for example, there could be the possibility also, thanks to the results of our project, if we think that this definition is the most adherent, is the most suitable for CAPTUS renewable energy carriers, that we promote a definition like that towards, for example, the integration of such definition in the new alternative fuel directive or in the new RED III that, as you know, is, let's say, still in full finalization. So, as I mentioned, your suggestions and your inputs in this phase of the project is very relevant, also because, let's say, having the possibility to, how can I say, find the most correct framework for our renewable energy carriers enable us, from one side, to look for permits and regulations that is more adherent to our carriers, but also look for potential incentives and supporting schemes that can facilitate the widespread and replication of the demonstration processes that we are, let's say, demonstrating, of course, in the project itself. Okay, so a few seconds less for answering, and let's see now the results. Okay, it seems that this definition looks the most adherent, according to your opinion, as the 50% of the respondents gave this as priority. But let's say the last question is very open, is up to you. Of course, as you understood with this last proposal of carbon negative fuel, we proposed an alternative definition not coming from European directives. So let's say, please feel free to propose what, in your opinion, could be the most close definition for our renewable energy carriers, also maybe according to your know-how of the European regulatory framework. So if you have any other idea, if you have any other suggestion to define our renewable energy carriers, let us know, because it is very important also to think about new definitions or new potential definition that, as I said, we can propose together with this one of carbon neutral fuel. This, as said, this is very open, so feel free to, how can I say, propose your own one. I can see now something is coming on the screen. Thank you, like CO2 derived fuels. Thanks. Also CCU-based energy carriers. That's great. You know, maybe in our case is also renewable driven, CCU-based. Net zero fuels. Thank you. Very close to carbon neutral, for example. So very, very interesting. I think I don't know if we can keep this maybe last question open for more time, because maybe during the whole webinar you can have further thoughts. But in any case, I would like to thank all of you for your feedback, because, as said, your input to guide us in this initial phase of the project is very, very valuable. So, Irene, I think I can give you back the word for the next step. And as you could see, there is no winner, because all the same scores.
Yeah, thank you very much, Stefano. Indeed, we will keep it as maybe homework, but also, yeah, open question to the audience. And of course, the chat is always open and ready to receive any kind of suggestion. But I think we already had interesting input for your task, and thank you for being with us. I know you have to run now. Thank you again. So now I would like to move back to the presentation, as we will have a panel discussion moderated by Dusan, Policy Director at EEIP. So I will leave the floor to Dusan to introduce the slot.
Thank you very much, Irene. I mean, this was very much inspiring, you know, the Stephanos, you know, the last test, you know, and I basically, you know, I think there's some echo, but what I would like to do, you know, is basically to try to move a little bit back, you know, from the last presentation, because what we had before, we had some kind of discussion of, I mean, now we are kind of with the definitions of the results, you know, we're focusing on kind of on the product. But what Konstantina was saying in her keynote speech, I mean, she kind of outlined, you know, this kind of centrality of the carbon capture and utilization in the energy transition and in the European Union. And from what we heard from the other presentations is that, you know, there is this kind of scalability of these processes, which necessarily kind of interact, you know, with the local perspectives. So basically, you know, these are kind of technologies, you know, which interact, you know, at the local level, which unlocks, you know, the need for understanding non-energy elements like a social acceptance, economic, business model implications, environmental, health, EU and national policies. So and furthermore, you know, basically kind of having awareness of this kind of complexity of the CCU at the technology level and testing, it's kind of, I think it's one of the keys, you know, for this kind of validation, replication, wider uptake. I mean, you know, I can say sort of privately, you know, I was a kickoff of this project event, and for me as an energy person, when I heard about algae and all of these kind of alternative fuels, I mean, kind of hits on a kind of warning bells, you know, really, because, you know, especially when you listen about production of it, how it interacts, you know, with the worker safety, with the local communities. So we have kind of validation and we have lots of discussions about technologies. But what I would like to do, you know, here at this discussion, to bring, you know, a little bit sort of like further up, you know, this sort of like, you know, non-technology elements, because I very strongly believe, you know, this will be the key, you know, to the uptake of it. So we try to balance the panel with the people with sort of technical and sort of non-technical perspectives. And I would very much like to invite Marine. I mean, from what you heard, I know you're pretty much like me, you know, you're like kind of like, you know, energy person, but, you know, kind of crossing over a community. What did you get out of all these presentations and out of this strange world of the carbon capture and utilization? If you can say, like, you know, about yourself a little bit, and then answer, please.
Hello, good morning, and thank you so much for having me. So yes, indeed, I'm an energy person, but I'm not a technical person. I'm really more focusing on the social dimension of it and of the ethical dimension of the energy and climate transition. So I always focus on the people, on the workers, on really the communities that can get affected. And, you know, from what was just said, what I noticed is that there are still a lot of discussions on how to turn this kind of project, this pilot project, into businesses. But for businesses to move from, let's say, the early startup stage to a broader acceptance, they need to think a little bit more systematically about the social challenges. But what I've seen is that the social dimension was seen as a challenge and not an opportunity to actually design and really ask the right question, ask deep questions about the form of acceptance that could come. And you know, the fact that we were discussing the definitions, I think it has to be in itself, it's like a big point, because when you discuss the definition, it means that you don't really, you englobe a lot of different nuances within one single definition. It can also feed, let's say, disinformation and mix-ups. And it is extremely important to be careful that they will, and to acknowledge that they will be mix-ups and disinformation along the way. So, you know, it's also about trying to be mindful of the potential reaction of the stakeholders in front of you, right? So I would say that for the time being, it's really super important to make sure that the communication is transparent And transparent doesn't mean everything will be okay, everything will be perfect. No, it's really about, we are going to make mistakes along the way, but please report to us whenever you see that. And I think it's like the project you are presenting that one day we hope will turn into businesses. It's really, really important that from the start, they take into consideration the viewpoints of the communities, of the people who are on board as citizen science, right? As really stakeholders who can report on something. If there is, for instance, a funky smell one night or several nights, maybe it's an indicator of something. So of course it will feed some concerns, but at the same time, if you say we also need you to get better, that's something that will kind of feed a positive mindset, a positive conversation, and really a positive outtake for those kind of projects.
Definitely, definitely. I mean, basically, I mean, kind of, it all goes back, to what Konstantina was saying at the beginning of the centrality of this, but very kind of transgressive nature of this kind of like, social economic implications of the CCU technologies. Filippo, I mean, you're at CINEA. I mean, you work with kind of very broad range of industrial project. I know you work on industrial symbiosis as well. I mean, this is also kind of crosses over. I mean, if you can say your perspectives on what you heard and what kind of came to your mind, and also, just say a few words about yourself first.
Yeah, sure. So indeed, my name is Filippo Gasparin, and I am delighted to be here and to join this very interesting panel. I'm working for CINEA, which stands for the European Climate Infrastructure and Environment Executive Agency, and we have been tasked by the European Commission to somehow support the implementation of the EU Green Deal. And we are doing this by also managing a very important program, which is the Clean Energy Transition Sub-Program of the LIFE, which is exactly looking at these non-technological barriers that plays a very important role. Because at the end of the day, we can see that there are many technologies that have been developed, but for one reason or another, these technologies are not taken up by the market. So what we are doing in more concrete terms is really to try to push companies to place sustainability within their business model. So already in the way in which they plan to generate value. And why that is because we do think that sustainability will push companies to look at two important aspects, time and others. Time because it will oblige companies to answer a basic question. So for how long do I want to remain in the market, in the business? And if a company want to stay for long, it won't be able to remain for many years if they are harming the community, for instance, in which they are operating. And others is because sustainability will again enable companies to connect with the needs of the others, of the society. And in this regard, what we have seen so far is that the clean energy transition has been driven by the industry sector. For instance, in the development of new technologies, smart grids, renewables, and so on. However, the next phase will be the electrification of the society. And this phase will not be driven by the industry, but by people, by end users. Meaning that it will be the end users who will decide whether to install a heat pump in order to heat their homes and so on. So in this regard, I do think that the industry sector can really create the best enabling conditions for this transition to happen within the time frame that we have available, which is not forever. It is actually quite 2030 and 2050. It will be really around the corner. So I do think that this local dimension is really important, and we need to find ways to really bring into the table, around the table, the different stakeholders from the private and the public sector, because many things need to be done, many investments need to be to reach the ground. And there is really a need for a comprehensive dialogue, I think.
Thank you, Filippo. I just would like to reiterate, for the participants, feel free to put your questions in the chat. Pelayo, I mean, you are kind of you sort of cross over, between sort of like non-technical elements, but you also sort of working on sort of technical side of the implementation of CCU. technologies. And I mean, what is, from what you heard, both from the presentations, but also from our first panelists, two panelists, I mean, what is your perspective? And again, you know, if you just say very briefly who you are and where you come from.
Well, thank you, first of all, for having me. I am Pelayo Garcia de Arquer. I am a professor and group leader in ICFO, Institute of Photonic Sciences, and we're working to develop decarbonizing technologies based on CCU, among others. So I really liked the comments of Marine about the need to be open and, you know, to say what we're doing, even if it's something that we find a problem. Just to you know, to people learn that they have not to be afraid of these emerging technologies, unlike maybe other technologies. And I think, to me, it is very important that this information is well sustained with techno-economic and life cycle assessment models that are informed by these scaling up initiatives, because, you know, it's best if we talk with numbers and we say, okay, we are worried about this, we are concerned about the potential impact this could have, because this is something that other technologies were not implementing. I think, to me, it is very, very challenging in this process also, like in terms of the development of this technology integration. I like to see today these projects where, you know, different technologies are integrated for a different application. And to me, the biggest barrier that exists for these technologies is they are developed sometimes alone. So that it's only when you go and integrate them that you realize there are entry barriers that you otherwise wouldn't anticipate. And unless you scale up this technology, since they're based on economies of scale, to be profitable, they need to be scaled up, and they cannot be scaled up and unless there is money, and people maybe are not prone to invest in these technologies, at least from the private sector, which I think is something that needs to be, you know, catalyzed somehow from the public sector, or I don't know, like that's my view.
Definitely. I mean, that's basically, I mean, you kind of, thank you for connecting, you know, also to Marine. I mean, it is something, you know, with these technologies that has to be kind of embedded into this kind of socio-economic elements and socio-environmental elements. They need to embed it into the process of developing technologies to ensure, you know, their kind of social acceptance, you know, so that the society and the public sectors and the other elements in this sort of like broader circle, they don't come as the afterthought, that they are like basically kind of like embedded from the beginning. Milana, thank you for your patience. And, you know, if you can say just very briefly about yourself, and also, you know, from what you heard, you know, from the three panelists and the presentations, and what is your perspective, and how do you think, you know, we can kind of best play up, you know, these processes?
Yes, thank you. So my name is Milana Ayzenberg. I'm the head of technology at a company called CAOX. CAOX is a young Norwegian company. What we do is commercializing technologies in the carbon capture and conversion space, primarily conversion to building materials. So what we have seen so far is that I think money talks a lot. So obviously, once and to the previous comment on the scale up and the economics of it and the life cycle assessment, I think it's very much true. It is really important then that when we valorize CO2, that we bring it to not only a useful product, but it also has to be economically viable. I think that's a really important part. So when you talk, and we've done a lot of business development, what we see is that when you talk to businesses, money comes quite often first, and obviously the reputational part of it as well. So most of the companies we've talked to, they are aware of the importance of decarbonization and preferably valorization of the what is considered to be waste. When it comes to the public perception, I think that the world needs to show some patience. We all learn. It's a learning curve for everyone. It's a technological learning, technology development. It's on the policy side, on the perception side. So everyone is doing the best we can. And I think the world kind of the outside the actual technology development, they need to understand that it takes time and we will make mistakes. Like Marina said, we will make mistakes. We will learn. We will do better next time. So it's just the nature of what we are doing. It's a new topic for a lot of us technologists. So I guess my message to the world is, show some patience. We are learning. We are doing as good as we can. Really.
No, I mean, definitely, it is basically, it's kind of, I mean, leaving, this sort of, we have to balance, this need for patience, but also for kind of implications, if there's not enough of the transparent and visible communication about the technologies, that we are opening the kind of back doors, for kind of misrepresentations. Marine, Milana mentioned this kind of like a socioeconomic elements, and I mean, how do you think this sort of like economy of development of these relatively new technologies, how do you think that might impact social perception, for social perspectives and acceptance?
I mean, there is this kind of clear path that when you set a new business somewhere, a new technology somewhere, it also has to be it also has to have local economic implication. Otherwise, there is no acceptance, right? So that requires really putting the CCU process within a more just transition process. With the training of workers, with the training of local economies, but that doesn't happen overnight. So it requires a lot of support from the municipality, from the region, from the state, where things are really embedded in where the project is going to develop, but also from kind of create a positive narrative also towards investors, because I mean, there are a lot of examples of project that kickstart because of some political decisions and so on, and they don't thrive because there is also a lot of, let's say, lack of economic forecast on certain topics that then make that the banks won't follow, so it's harder to finance the project, etc. But it doesn't have to be this way, because if the community actually likes the project, if they really want to fight for it, they will also make their ways towards different business models, such as cooperative models, right? They exist. There are companies that have been taken over by their workers and now are formed towards cooperative models, and not only like public companies that are quoted somewhere. So it's really about kind of finding the balance, also because there is such a social purpose in developing CCU, because it is for the common good, but it's also really hard to to create the right framework, the right narrative, showing that when you decide, when the community accepts CCU within their premises, it's for the greater good, because we don't see it. We don't see the carbon in the atmosphere. We breathe it, but we don't see it, right? But at the same time, nobody likes pollution. So we will always do, our communities will always do everything in their power to just try to avoid pollution. So it's also really important to have the discussions at really the start, so that the community that will get a CCU treatment plant, whatever it looks like, will not be negatively impacted. And there is also this kind of really think it's important to mention that traditionally the most marginalized communities, so the poorest, people with let's say a different racial background, people with disabilities, etc., they have been overall way more exposed to pollutants than the richest communities, right? So it's really that I believe that the energy transition is the time to fix those kind of imbalances. So if we build CCU, they have to be built with the community, and they have to be built in a way that will not harm them. So it's really important at all levels to do no harm, right?
Definitely, and it kind of turns the tables a little bit because, I mean, on society level and also not so much on the business level, but we always speak about the carbon as kind of dead end and sort of like the bed end, you know, of things. And with there is a clearly potential with the carbon capture and utilization that we can sort of basically perceive, you know, this sort of carbon also as sort of, you know, there's potential in this. But you're totally right, you know, it has to put on a kind of right foot and try to do it concretely. Filippo, I mean, you know, EIP, we work with the companies, we work for like, you know, a number of projects, but also with a lot of companies in the energy sector, but, you know, suppliers and all kinds of people and consultants. You deal, you know, on the policy level. I mean, what can we do, you know, to kind of help, you know, these tables to turn and to kind of create visible sort of opportunities for the positive perception of carbon capture and utilization?
Yeah, I think what we really have to do and to invest time on is to develop metrics that can capture again the value of the sustainability, so the value of doing things that are not harming the others. And these metrics are not there at the moment. We are still stuck with concepts from the past. So in order to capture the value of a company, we use aspects such as net value income, free cash flow, but we really need to find to go a step further. And of course, this is difficult. This is difficult because we need also to embrace a more broader concept of sustainability. So not only looking at energy efficiency as a standalone process somehow. And this is difficult because, again, also companies need to be able to understand and to measure the progress that they are doing in becoming sustainable. And this is crucial because if you're not able to monitor the progress that you are doing and you just try hard, sooner or later you will also lose confidence on what you are doing. And as a manager, you will not even be able to motivate the people that are working with you. And in this regard, I think also we need to invest time also with regard to capacity buildings and trainings, because I do see that this is really the limiting factor for the clean energy transition. I mean, the clean energy transition will offer huge opportunities for the business sector. That is a fact. The only competition that I think companies will fear is about skills. So really to employ the most qualified and trained people. And this is something that should be looked at again from different perspectives. So from the public and the private perspective. So come up with schemes that can really put in place the best effective training processes. And with regard to the social part, I do think that the concept of energy communities that somehow slowly are taking up, I think it is very important because the main, to me, mission of an energy community is really to train the people about the complexity behind their domestic socket. So all the things that are around. And so this is the first step for also for the community to embrace somehow the technology changes and to understand the difficulties in delivering clean, cheap, affordable electricity to the society.
Thank you, Filippo. I mean, we have very interesting comments in the chat section from Monique. I mean, she's coordinating the CAPTUS project and she made a presentation and basically talking about kind of centrality of the stakeholder engagement already embedded into the CAPTUS project. I mean, I wish, you know, I could sort of bring Monique in, but, you know, I think we are basically running out of time. To conclude, you know, I have to say, and I mean, EIP, you know, we are responsible on kind of replication side, you know, for the work packages on this project, and this is in the way, you know, we kind of try to sort of try to kind of, design, the discussion, to sort of drive, a little bit more, towards the kind of practicalities, what can we do, with the work being done as this project and some other projects. So at the end, I would like to thank you all for all the participants. First of all, for participating, all the speakers, for great presentations, a super interesting discussion. Especially big thanks, to kind of like non-usual suspects like Marine and Filippo, who kind of, I know how much kind of reluctance, they might had, looking at the program, of this like a CCU, and I can very much, kind of share that kind of, and thank you for kind of, thank you for bringing, this very, very important perspective. And finally, great thanks, to our team, Irene, Olas and Anna, and they've been like, really running it here. And I think, Irene might have to say something at the end.
You are muted, Irene. Still muted.
Thank you.
Thank you. Bye. Thank you.